Q6680. If the static pressure tubes are broken inside a pressurized cabin during a high-altitude flight, the altimeter would probably indicate A. Sea level. B. Lower than actual flight altitude. C. Higher than actual flight altitude. The correct answer is B. In an aircraft with a pressurized cabin, the altimeter measures altitude based on the difference between the static pressure outside the aircraft and the static pressure inside the aircraft. The static pressure is typically obtained through static pressure tubes or ports that are positioned in areas of undisturbed airflow outside the aircraft. If the static pressure tubes inside a pressurized cabin are broken or compromised during a high-altitude flight, the altimeter will no longer receive the correct static pressure reading. Instead, it will be influenced by the pressurized air inside the cabin. When the static pressure tubes are broken, the altimeter will sense the higher pressure inside the pressurized cabin, which is maintained to provide a comfortable environment for the occupants. Since the altimeter's reference pressure is higher than the actual outside air pressure at the aircraft's altitude, it will indicate a lower altitude than the actual flight altitude. This discrepancy occurs because the altimeter is designed to measure altitude based on the assumption of a standard decrease in pressure with increasing altitude. However, when the altimeter receives a higher pressure reading due to the broken static pressure tubes, it interprets it as being at a lower altitude, causing the altimeter to indicate a lower reading. 6677. Pitot-static system errors are generally the greatest in which range of airspeed? A. Low airspeed. B. High airspeed. C. Maneuvering speed. The correct answer is A. The pitot-static system in an aircraft is responsible for providing key measurements related to airspeed and altitude. It consists of two primary components, the pitot tube and the static ports. The pitot tube is positioned on the aircraft's exterior and is designed to measure the impact pressure of the oncoming air. It provides the airspeed indication by comparing the impact pressure, dynamic pressure, with the static pressure obtained from the static ports. The static ports, on the other hand, are usually located on the side of the aircraft and capture the static pressure of the surrounding air. This pressure is used to measure altitude and provide the necessary reference for the airspeed indication. In the context of pitot-static system errors, the greatest errors typically occur at low airspeeds. There are a few factors contributing to this. 1. Position error. At low airspeeds, the airflow around the aircraft can become disrupted, causing inaccurate readings on both the pitot tube and static ports. For example, when the aircraft is in a high angle of attack or during certain flight maneuvers, the airflow can become turbulent, leading to inconsistent pressure readings. 2. Instrument error. Instruments in the cockpit, such as the airspeed indicator and altimeter, can introduce errors at low airspeeds. These errors can arise from mechanical limitations or instrument design, which may not accurately account for the specific conditions encountered at low airspeeds. 3. Calibration error. The pitot-static system is typically calibrated for a specific range of airspeeds. Errors can occur when the system is operating outside its calibrated range, such as during extremely low airspeeds, where the calibration may not be as precise. Due to these factors, the accuracy and reliability of airspeed and altitude indications from the pitot-static system tend to be compromised at low airspeeds. It is important for pilots to be aware of these potential errors and cross-reference their instruments with other available data, such as GPS or visual cues, to ensure accurate and safe flight operations. 6679. If a pitot is clogged, which instrument would be affected? A. Altimeter. B. Airspeed indicator. C. Vertical indicator. The correct answer is B. The pitot tube is an essential component of the aircraft's pitot-static system, which measures airspeed, altitude, and vertical speed. It is designed to capture the impact pressure of the oncoming air, providing the airspeed indication. When the pitot tube becomes clogged or blocked, it restricts the airflow into the system, leading to inaccurate or unreliable airspeed indications. Here's how a clogged pitot tube affects the airspeed indicator. The airspeed indicator relies on the difference between the impact pressure, dynamic pressure, from the pitot tube and the static pressure from the static ports. The dynamic pressure is higher due to the forward motion of the aircraft, while the static pressure remains relatively constant. If the pitot tube is clogged, the dynamic pressure cannot be sensed, and the airspeed indicator will no longer receive accurate information about the airspeed. As a result, the airspeed indicator may freeze at a particular reading, show zero airspeed, or fail to provide any indication at all. This can be problematic for pilots, as airspeed is a critical parameter for various aspects of flight, including takeoff, landing, maneuvering, and stall prevention. Without reliable airspeed information, pilots may have difficulty maintaining proper control of the aircraft and making informed decisions. 7289. The pitot system impact pressure for which instrument? A. Altimeter. B. Vertical speed indicator. C. Airspeed indicator. The correct answer is C. The pitot system in an aircraft is responsible for measuring the impact pressure of the oncoming air, which is then used to determine the aircraft's airspeed. The instrument that utilizes this pitot system impact pressure is the airspeed indicator. The airspeed indicator is a critical instrument in the cockpit that provides information about the aircraft's speed through the air. It measures the difference between the impact pressure from the pitot tube and the static pressure from the static ports. The pitot tube is specifically designed to capture the impact pressure, also known as the dynamic pressure, caused by the aircraft's forward motion through the air. This dynamic pressure increases as the aircraft's speed increases and decreases as the speed decreases. The airspeed indicator uses this dynamic pressure from the pitot tube, along with the reference static pressure, to display the airspeed of the aircraft. The dynamic pressure is transmitted to the airspeed indicator through the pitot system, which consists of the pitot tube and associated plumbing. By comparing the dynamic pressure, pitot system impact pressure, with the static pressure, the airspeed indicator is able to provide an accurate indication of the aircraft's airspeed. It displays this information to the pilot using a needle or digital readout, allowing them to monitor their speed and make necessary adjustments during flight. 6712. If both the ram air input and drain hole of the pitot system are, what airspeed indication can be expected? A. Decrease of indicated airspeed during a climb. B. Zero indicated airspeed until blockage is removed. C. No variation of indicated airspeed in level flight even if large power changes are made. The correct answer is C. The pitot system in an aircraft is responsible for measuring the impact pressure of the oncoming air, which is used to determine the aircraft's airspeed. The pitot system consists of the pitot tube, which captures the impact pressure, and the associated plumbing that carries the pressure to the airspeed indicator. The ram air input of the pitot system allows the pitot tube to be exposed to the dynamic pressure of the oncoming air during flight. This dynamic pressure, along with the static pressure obtained from the static ports, is used by the airspeed indicator to provide an indication of the aircraft's airspeed. The drain hole, on the other hand, is a small opening in the pitot tube or the plumbing that allows any moisture, condensation, or other contaminants to drain out of the system. It prevents the accumulation of debris or water that could potentially block the pitot tube or affect the accuracy of the airspeed indication. If both the ram air input and the drain hole of the pitot system are blocked, it would disrupt the flow of air and prevent the dynamic pressure from reaching the airspeed indicator. In this scenario, the airspeed indicator would not receive any changes in dynamic pressure, resulting in a lack of variation in the indicated airspeed.